Today in the digital world, everything is going to connect to internet. Our transactions, shopping, data, and even our medical files. Everything is done through internet, where the majority of the time we are interacting with anonymous. If we don't know how to use and profit of technology, we may be a victim of malicious actions. Well, we need cybersecurity to secure ourselves. Blockchain, one of the latest and promising cybersecurity technologies, will be our topic for today. Let's explore it. Our session will be focusing on 3 topics: what is the blockchain, why we need it, and how it works. The first question to come in mind when we hear about the blockchain is to ask, what is it? Over the time, people relied on their memories to keep track of their goods. Then they created the ledgers, which has evolved to be the spreadsheets within the PC's era. Later, they developed the nowadays distributed database. But the need of a decentralized secured structure comes with the blockchain. Therefore, the blockchain is a suite of shared distributed ledger that can be programmed to record and track anything of value over time. Today's business ledgers rely on centralized, trust-based third-party system which create bottleneck and slow down transaction settlement. Blockchain was created to address these limitations due to its decentralized, distributed and shared ledger, immutable, tamper-resistant structure, and the no need of intermediaries. Before starting with how blockchain works, we should define 2 terms, the block and the node. The block is the set of transactions that are grouped together to improve logical organization and scalability, where the node is any participant on the network. Keep in mind that it may take different roles in the network. As an overview, the picture below depicts the process of forming or adding a block to the blockchain, starting from the transaction definition, then transaction authentication. In step 3, there is the block creation. Block validation occurs in step 4, and at the end, there is the block chaining. The first step of forming a block starts with the transaction definition. It's when 2 nodes in the blockchain network agree on a transaction. The sender node creates a transaction and sends it to the network. The transaction could include information such as the public address of the receiver, transaction details like amount to transfer, reference to previous transaction, and much more. The sender digital signature proves the authenticity of the transaction. Step 2 is the transaction authentication. It's when the nodes in the network receive the transaction message and validate the authenticity of the message by verifying the digital signature. The authenticated transaction is placed in the pool of pending transactions. Then the block creation took place when one of the nodes in the network encapsulates pending transaction in a block and alerts the nodes across the network about the newly built block for its validation. The validation occurs when the validator nodes in the network receive the new block and work to validate it through an iterative process that requires consensus from the majority of the nodes in the network. These validator nodes are often referred as miners. At the end, once all transactions are validated, the new block is chained with the previously validated blocks, forming the blockchain. At this point, the current state of the ledger is broadcasted to the network. This is the end of part 1. Thank you for your attention. If you want to know about blockchain features, kindly watch part 2.